Hello, very good morning to you. Yeah, yesterday evening we took some class, so that is belongs to the application of the Schrodinger wave equation I told in yesterday. So we finished the two topics till now. One is wave particle duality. We finish, and the second one is we are going to finish, that is the Schrodinger wave equation. That in the Schrodinger wave equation, time dependent and time independent Schrodinger wave equation we are uh, finishing. Schrodinger time dependent and time independent wave equation we are finishing, correct? Schrodinger time dependent and time independent wave equation we are going to finish. Once we have to finish the Schrodinger time dependent and time independent wave equation, we have to take that is the expression you have to going to take. That expression is belongs to what? So that is the eigenvalue problem. Eigenvalue problem we are going to discuss. What is the eigenvalue problem? So once you have to take the eigenvalue problem, so in that eigenvalue problem we are going to take that is very important application we are going to take in that eigenvalue problem. Clear? So right. So eigenvalue problem we are going to discuss. In the eigenvalue problem, maybe so many problems you have. Particle in a box. So variety of the eigenvalues are there. So maybe it took the so many days. In the eigenvalue problem, linear harmonic oscillator also quoted here only, but I have to teach in somewhere. But first I have to teach whatever, this is the graduation level only, but I have to teach in terms of different way. You try to understand and you try to learn the quantum mechanics. You know the Schrodinger wave equation, Schrodinger time independent wave equation you have to take. So what is the Schrodinger time independent wave equation? The Schrodinger time independent wave equation is del square psi plus 2m by h cut square into del square psi plus 2m by h cut square into e minus v into psi is equal to 0. Del square psi plus 2m by h cut square into e minus v into psi is equal to 0. This is the Schrodinger time independent wave equation. If you know the Schrodinger time independent wave equation, we are going to divide here. Suppose you able to take here, so two varieties of the systems I have to teach to you. Here one system you are able to take when the energy, the E is total energy is greater than V. This is the first you have to take here. Now you able to consider here E is less than V, you able to take. So E is greater than V and E is less than V you have to take. So then what is going to happen, you have to see, your Schrodinger wave equation will become del square psi plus 2m E by h cut square into E minus V into psi is equal to 0. As it is, it will come, where you have to take here so 2m is divided by h cut square, 2m is divided by h cut square into E minus V is equal to k square, you have to write it is. So therefore you able to take this one, del square psi plus k square psi is equal to 0. Del square psi, k square psi is equal to 0. Now you have to write it is here. So when E is less than potential energy V, so therefore our Schrodinger equation will become del square psi minus 2m is divided by h cut square into V minus E into psi you have to take, so which is equal to 0. Here also you able to know what is this. So where you have to take here, so one more k square you have to write it is, this is 2m by h cut square into V minus E when so your potential energy is greater than the total energy. Now our expression will become del square psi minus k square into psi is equal to 0, minus k square into psi is equal to 0. So therefore, how we have to solve these expressions once you have to see. When E is greater than capital E, when E is greater than capital V, when E is less than capital V, and V is less than capital V. So therefore, our Schrodinger wave equation, it will become, our Schrodinger wave equation, del square psi plus k square psi is equal to 0, del square psi plus k square psi is equal to 0. For one dimensional, for 1D, what we have to write? So this is the d square psi plus k square psi is equal to 0. You have to write it is f dot d into psi is equal to 0. Therefore, f dot d is equal to d square plus k square is equal to 0. D is equal to plus or minus I k you are going to get. So therefore, we need to write the solution. Psi is equal to a e to the power of I k x plus b e to the power of minus I k x. So therefore, our wave function is, how it will come? Our wave function is sinusoidal wave function. Our wave function is sinusoidal function. This is very, very important when E is greater than V. Similarly, here you have to take, so what is this? Del square psi minus k square psi is equal to 0. Here you have to take for one dimensional, for 1D, what we have to write it is d square psi minus k square psi is equal to 0. So therefore, so d square f of d you have to write in terms of f of d into psi is equal to 0. F of d is equal to d square minus k square is equal to 0. D square is equal to k square. D is equal to plus or minus k. So therefore, your solution is psi is equal to a e to the power of kx plus b e to the power of minus kx is there. So therefore, our wave function is psi, it is become as a exponential wave function. Which wave function it is? It is a exponential function. This is very, very important. This function we are going to take it as a exponential curve or exponential wave function you are going to get based on the wave function limits you able to write. This is the general introduction. To apply the eigenvalue problem, we need the boundary conditions. Majorly, three varieties of the boundary conditions are there. The first variety of the boundary condition once you have to take. The first variety of the boundary condition is, what is that boundary condition? The rigid boundary condition. This is the first variety of the boundary condition is rigid boundary condition. Maybe you have to take it as a for infinite height boundary condition. Which height it is? Infinite height boundary condition. Suppose you have to take a one dimensional box, you able to consider one dimension. Box length is 0 to L. Box height you may take up to the infinite you have to consider. This is the infinite height is there or rigid boundary condition. Clear? Now you have to write it as a finite boundary condition. First you have to take the potential step you have to consider. This is a potential step. Now you able to take, so there is a boundary at x is equal to 0. There is a boundary is there. So from this boundary what we have to write, this is the medium 1, this one you have to take it as a medium 2. Now wave is propagating and incident on the boundary. Some portion of part should be reflected back, some portion of part should be transmitted in that medium. Clear? So now you have to take, here the wave function is psi 1, here the wave function you have to take it as a psi 2 wave function you able to consider. Now, we need to write the boundary conditions. How we have to write the boundary conditions? There are these two varieties of the boundary conditions you have to remember. If it is a system will be like this, you have to apply this boundary condition. If system will be finite height, so you have to apply this boundary condition. If system is a finite height, so you have to apply this boundary condition. What is that height? So maybe you have to take that height is equal to V. So whatever it may be, you have to consider it that height is equal to V, you have to take. Clear? So now you able to take here. So this boundary condition is a rigid boundary condition. This boundary condition we call it as a continuous boundary condition or finite height boundary condition. What is that condition? We have to learn. So what is that condition? A psi of x is equal to 0 at x is equal to 0. Psi of x is equal to 0 at x is equal to 0. Psi of L is equal to 0 at x is equal to L. So this is the for a infinite height boundary condition. For the rigid boundary condition, what is that? Psi of x is equal to 0 at x is equal to 0. Psi of L is equal to 0 at x is equal to L. Clear? Now you have to take a continuous boundary condition. That is a continuous boundary condition means a finite height boundary condition. What is that boundary condition? Now you have to take at the boundary psi 1 is equal to psi 2. Psi 1 is equal to psi 2 at x is equal to 0. Psi 1 is equal to psi 2 at x is equal to 0. Dou psi 1 by dou x is equal to dou psi 2 by dou x. Dou psi 1 by dou x is equal to dou psi 2 by dou x at x is equal to 0. This is the which boundary condition? For a continuous boundary condition, or you able to take for finite height boundary condition. What is finite height boundary condition? Psi 1 is equal to psi 2 at x is equal to 0. Dou psi 1 by dou x is equal to dou psi 2 by dou x at x is equal to 0. This is a continuous boundary condition. So not only that, so we have to take one more boundary condition is there. That is a bound state boundary condition. Bound state. So for a bound state, there is a boundary condition is there. So what is the bound state you have to take? So there is a potential barrier is there. So this is the potential barrier you have to take. So in this potential barrier, this barrier height is 2a minus a2 plus a, you have to write it is minus a2 plus a. Here how many things are there? This is the medium 1, this one you have to take it as a medium 2, this one you have to consider as a medium 3 you have to consider. So here wave function you able to take is psi 1, here wave function you have to take it as a psi 2, here wave function you have to consider as a psi 3 wave function you have to consider. Clear? Psi 1, psi 2, psi 3 wave function you able to take. Now you have to write it is here kinetic energy you have to take it as a, which one you have to take? Here kinetic energy of the particle you are going to take it as a negative. Here kinetic energy of the particle you are going to take it as a positive. Here kinetic energy of the particle you are going to take it as a negative. Kinetic energy of the particle you are going to take it as a negative. So here you able to take, so what is the height of this here at x is equal to minus a, that height is equal to v, at x is equal to plus a, this height also you have to consider as a v only, you have to consider at x is equal to plus a also. Here the potential is equal to how much is there? The potential is equal to 0 here. So the potential is v potential is existing in the region 1 and region 2. Such type of system we call it as a bound state system. This bound state system we call it as potential barrier system also. what is the boundary condition for a such type of system? Once you have to take, so the boundary condition is 1 by psi 1 into 1 by psi 1 into dou psi 1 by dou x, dou psi 1 by dou x at x is equal to minus a, at x is equal to minus a, which is equal to 1 by psi 2 into dou psi 2 by dou x, dou psi 2 by dou x at x is equal to minus a. This is the first boundary condition. We have to write at x is equal to minus a, at x is equal to minus a, what is your boundary condition? 1 by psi 1 dou psi 1 by dou x is equal to 1 by psi 2 dou psi 2 by dou x at x is equal to minus a. Similarly, you have to take 1 by psi 2 dou psi 2 is divided by dou x at x is equal to plus a, which is equal to 1 by psi 3 dou psi 3 is divided by dou x, dou psi 3 is divided by dou x at x is equal to plus a. So, what we have to write? At x is equal to plus a we are going to take. This is the boundary condition. So, what boundary condition? This boundary condition is a very essential boundary condition, that is the bound state boundary condition. Once again you have to see these three boundary conditions are very important. The first one is rigid boundary condition for infinite height. The second one is continuous boundary condition for finite height. If it is infinite height, psi of x is equal to 0 at x is equal to 0, psi of L is equal to 0 at x is equal to L. Here for continuous boundary condition for a finite height, psi 1 is equal to psi 2 at x is equal to 0, dou psi 1 by dou x is equal to dou psi 2 by dou x at x is equal to 0. This is the very important, this is continuous boundary condition. Now, you are able to take bound state boundary condition. What is the bound state boundary condition? Here this type of system we call it as a bound state system. The particle is bounded here. So, 1 by psi 1 dou psi 1 by dou x at x is equal to minus a is equal to 1 by psi 2 dou psi 2 by dou x at x is equal to minus a. So, now you are able to take 1 by psi 2 dou psi 2 by dou x at x is equal to plus a is equal to 1 by psi 3 dou psi 3 by dou x at x is equal to plus a. This system, this condition we call it as a bound state boundary condition. This bound state boundary condition belongs to whom? Belongs to the another boundary, that is the potential barrier type boundary condition. Now, we have to take the eigenvalue problem. According to your syllabus, the first problem is a particle in a box. Which box it is? One dimensional box, two dimensional box, maybe three dimensional box. So, whether it may be the particle, you have to take it as a box. Now, we have to write, this is the first application according to your syllabus. I am teaching particle in a box, particle in one dimensional box, particle where we have to take one dimensional box. How we have to write it is, now you able to take a free particle, that particle must be free particle, a free particle execute, a free particle exist in one dimensional box. A free particle in 1D box, you have to write it is a free particle in 1D box. How we have to represent this is, so there is a free particle is there. Now, the box length is equal to 0 to L, that box height is equal to, you have to write it as a infinite height is there, that particle is free particle. So, the potential energy is equal to 0. So, therefore, what we have to write, that particle mass is equal to m, one particle is existing there. Now, you have to write here the potential V is equal to infinite. Here also you have to take the potential V is equal to infinite, you have to going to get it. So, the region you are going to take only one region is there, that region is equal to 1. So, this region you have to take. So, what is the condition for the potential? So, we need to write the condition for the potential according to the one dimensional box. V of x is equal to 0. When it will be 0, V of x is equal to 0. When it will be 0, when 0 is less than x is less than L. When 0 is less than x is less than L, this is going to become as a 0. When it will be infinite, so this V of x is equal to infinite. When it will be infinite, it is going to infinite when x is less than or equal to 0, when x is greater than or equal to 0. When x is less than or equal to 0, when x is greater than or equal to L, you have to write. This is very, very important. This is the potential we have to define. First we need to define the potential. This is the first step. Whatever it may be, whatever problem they may ask, first you have to define the potential corresponding to that box. You have to remember a free particle in one dimensional box. A free particle is existing in one dimensional box. How we have to define? So, we are going to define the potential. After defining the potential, now you have to take the Schrodinger wave equation. So, what is the Schrodinger time dependent wave equation we are taking? Schrodinger time independent wave equation we are writing. Schrodinger time independent wave equation. So, what is the Schrodinger time independent wave equation? So, according to your previous knowledge, so del square psi plus 2m is divided by h cut square into e minus v into psi is equal to 0. So, this is the Schrodinger time independent wave equation. Now, we have to apply the, so for a free particle you have to see how we are going to apply. For one dimensional box, we are going to take it as a, for one dimensional box. So, for 1D, for one dimensional box, the Schrodinger equation will become, so dou square psi is divided by dou x square plus 2m by h cut square into e minus v into psi is equal to 0. For a one dimensional box we have to write. For a free particle, your particle is going to take it as a free particle. So, what is will happen? So, potential is equal to 0. Your potential is equal to 0 means dou square psi is divided by dou x square plus 2m by h cut square into e minus psi e minus 0 into psi is equal to 0. Now, you have to write it is dou square psi is divided by dou x square plus 2m e is divided by h cut square into psi is equal to 0. This is your expectation of the Schrodinger wave equation for a free particle in a one dimensional. Now, we need to write it as you have to solve where k square is equal to dou square psi is divided by dou x square plus 2m is divided by h cut square is equal to k square into psi is equal to 0, where k square is equal to, you have to define where k square is equal to 2m e is divided by h cut square. This is your k square value, correct. So, where k square is equal to 2m e is divided by h cut square. Now, you have to substitute here. So, d square psi plus k square psi is equal to 0, d square plus k square into psi is equal to 0. This expression will become f of d into psi is equal to 0. So, therefore, d square plus k square is equal to 0. You have to find the roots. D square is equal to minus k square, d is equal to plus or minus I k. So if the roots are imaginary, so therefore you have to write the solution psi of x is equal to a e to the power of I k x plus b e to the power of minus I k x. We are writing the solution. This is the solution of corresponding to that problem. Now we need to apply what we have to apply. We need to calculate this wave function. We have to calculate by using the boundary conditions. We need to calculate the wave function. How we have to calculate the wave function? Our wave function is psi of x is equal to a e to the power of I k x plus b e to the power of minus I k x. This one we are getting. Now we have to apply the boundary conditions. You have to apply the boundary conditions. What are the boundary condition for a finite for boundary conditions? So this is the one dimensional box for infinite height. For a infinite height boundary condition. What is the infinite height boundary condition? So the apply the boundary conditions for infinite height. The first boundary condition is psi of x is equal to 0 at x is equal to 0. Psi of x is equal to 0 at x is equal to 0. You have to apply in that equation a e to the power of 0 plus b e to the power of 0. So therefore a plus b is equal to 0. Therefore b is equal to, we need to write it as minus a. Now you have to substitute this b is equal to minus a in above expression. How we have to write? Psi of x is equal to a e to the power of I k x minus a e to the power of minus I k x, because you have to write it is a you able to take the common e to the power of I k x minus e to the power of minus I k x is divided by, you have to rearrange. So 2I into 2I you have to rearrange. So therefore 2IA into e to the power of I k x is divided by e to the power of minus I k x is divided. So this is equal to, going to write it as sin k x. We have to write it is going to take it as a sin k x. So therefore psi of x is equal to 2IA into sin k x. We have to write it is psi of x is equal to, you have to take one constant. That constant is n. You have to take n sin k x. This is the psi of x is equal to n sin k x. Now we have to apply the second boundary condition. We are getting the first boundary condition. We are getting one wave function, that is n sin k x. We are getting that wave function. Now you apply the second boundary condition. What is your second boundary condition? Psi of L is equal to 0 at x is equal to L. Psi of L is equal to 0 at x is equal to L. So at x is equal to L, psi of L is equal to n sin k L it is there. But psi of L is equal to 0 n sin k L. So here, so n is not equal to 0, because this is going to become as a equal to 0. So therefore sin k L is equal to 0. When it will become 0, k L is equal to n phi, where n is equal to 0, 1, 2, 3 and so on. So therefore we have to write it is k is L is equal to n phi. K is equal to, we need to write it is n phi is divided by L. So if you know the k is equal to n phi is divided by L, what we have to write it is sin of x, psi of x is equal to n into sin n phi is divided by L into x. We have to write it is psi of x is equal to n into sin n phi x, n phi is divided by L into x. Now we need to calculate the n value. How we have to calculate the n value? So n value, for calculating the n value, we have to use the normalization condition. Which one we have to use? Normalization condition we are going to use. You have to use the normalization condition for finding what? Normalization condition you have to use for finding what? Normalization condition for finding the n value. So what is your normalization condition? Integral lower limit to, so integral lower limit, which one it is? Lower limit to upper limit modulus of psi square into dx, which is equal to 1. This is the normalization condition. What is your normalization condition? Your normalization condition is integral of lower limit to upper limit, integral of lower limit to upper limit modulus of psi square into dx is equal to 1. Now you have to apply lower limit is equal to 0, upper limit is equal to n, modulus of psi square is equal to your psi of x is equal to n5 by L into x whole square into dx, which is equal to 1. Now you have to write it is modulus of n square is equal to n square integral 0 to L sin square n5x by L into dx is equal to 1. But we don't know the sin square theta is equal to 1 minus cos 2 theta is divided by 2. We know that so formula, the trigonometrical formula sin square theta is equal to 1 minus cos 2 theta is divided by 2. So you have to apply here. So therefore n square into integral 0 to L sin square theta is equal to 1 minus cos 2 n5x is divided by L is all divided by 2 into, so which one we have to write? It is dx, which is going to take it as a1. Now the two integrations we are getting, so n square into integral 0 to L, n square into integral 0 to L 1 by 2 into dx, 1 by 2 into dx. So minus integral 0 to L cos 2n5x is divided by L into dx, which is going to take it as a equal to 1. Now you have to write it is what we are going to write. This is the even function. Now this limit is odd limit. If even function odd limit, you have to integrate and you substitute, you are going to get it as a 0 you have to get. Now n square into integral dx is equal to x, you have to apply the upper limit and lower limit, which is going to take it as a L. So therefore n square into L is equal to 1. N square into L is divided by 2, it will come, so that is L by 2 you are going to get it. So therefore how much you are going to write here? I am writing, so n square is equal to, so 2 is divided by L, n is equal to square root of 2 is divided by L. This is the normalization constant corresponding to your problem. So therefore your wave function it will become, how you are going to get the wave function? Psi of x is equal to your wave function is n sin n5 by L into x. This is your wave function. So therefore psi of x is equal to, what is your n? Your n is going to write it is root 2 by L into sin n5 by L into x. n5 is L is into x. This is the corresponding wave function. For a wave function equation for one dimensional, wave function equation for free particle in one dimensional. Free particle free particle in one dimensional. Which dimension it is? One dimensional. Free particle in one dimensional, right? One dimensional box. This is very, very important. Any eigenvalue have to solve, you able to get. So which one you have to get? So you are going to get the wave function. So that wave function is, this is the that wave function. Next, what we need to calculate? So we have to calculate the energy value. So now how we have to calculate the energy? Now you have to observe this wave function. Suppose this is one dimensional box. Graphically you have to observe. Maybe you able to take at x is equal to 0, that box length here, that x is equal to L, you have to write it is, now you able to write it is n is equal to 1. If n is equal to 1, you have to take it as a psi of x wave function, you have to write it is psi n of x or psi of x you have to take, where n is equal to 1 you able to get it, your wave function will be like this. Your n is equal to 1, so n is equal to 0, there is no wave because sin 0 is equal to 0 it will come, so there is no wave. So that is why n is equal to 1, there is a wave it will come. If n is equal to 2, so how it will come? This is the wave function will become as a, it will change like this, wave function it will become like that. At the 2 so nodes you able to get. If n is equal to 3, if n is equal to 3, our wave function can become, like this it will come. So now you have to observe here how you able to take this wave function. Now you have to observe, if n is equal to 0, so there is no wave function, Why it is no wave function? Because sin 0 is equal to 0. If n is equal to 1, there is a wave function is existing. How many nodes are there? So there is a nodes, there is no displacement part, we call it as a node. So 2 nodes are existing. How many nodes are existing? 2 nodes. If n is equal to 2, how many nodes are there? 1 and 2 and 3. How many nodes are existing? So 3 nodes are existing. If n is equal to 2, 3 nodes are existing. If and so on, if n is equal to n, how many nodes are existing? Once you have to take here, n plus 1 nodes are existing in that wave function. Clear? That wave function is there. So 2 nodes are there, or in psi 2 of x, here you have to take n is equal to 3. So 3 nodes are there in psi 3 of x. Here 2 nodes are there, where here psi n of x you have to take. Clear? So this is the very, very important expression you are going to write here. Not only that, so you able to find out the energy value. How we have to calculate the energy value for a one dimensional free particle? In one dimensional free particle, energy value we need to calculate. Now you have to say, we know that k square is equal to 2m is divided by h cut square. This value already we know, previously we assumed this value. Now k we found, k is equal to n phi by L whole square, which is equal to 2m is divided by h cut square. Clear? So now n square phi square is divided by L square, which is going to take it as a 2m is divided by h cut square. So therefore you have to rearrange this expression. E is equal to n square into phi square h cut square is divided by 2m L square. This is the energy of a one dimensional box. So now again I am rearranging. Here you have to take E is equal to, this is the first expression, n square into phi square h cut square is divided by 2m into L square. This is the energy expression you have to write it is. But we know that h cut is equal to h by 2 phi, h cut is equal to h by 2 phi, h cut square is equal to h square is divided by 4 phi square. So, therefore, that energy value is equal to n square phi square h square is divided by 4 phi square means 8 m. So, phi square into L square. Phi square get cancelled. Therefore, E is equal to n square h square is divided by 8 m L square. This is the another expression in terms of the h value. So, in terms of the h value, so these two expressions we got it as E is equal to n square phi square h cut square is divided by 2m L square, or E is equal to, you have to write it E suffix n is equal to n square h square is divided by 8m L square. So, these expressions we call it as a energy values, energy of the free particle in a one dimensional box. What are those expressions? These expressions are energy of the free particles, energy of free particle, where it is existing free particles in 1D box, in one dimensional box, free particle in one dimensional box, energy of the free particle in one dimensional box, we are getting this one. So, based on this, how we have to interpret the graphical representation? Now, you have to see the, again I am writing this expression n is equal to n square phi square h cut square is divided by 2m into L square, or so En is equal to, we have to write it is n square h square is divided by 8m L square. This is the energy of a one dimensional box. Now, you remember this graphical representation of the one dimensional box. That box is infinite height is there, maybe you have to consider as a infinite height box, you have to consider that box length is equal to 0 to L, you able to take here. So, now you have to take, so for n is equal to 0, there is no energy level, the ground state here n is equal to 1, there is a energy is there, that is E1 is equal to phi square h cut square is divided by 2m L square. Now, you have to apply n is equal to 2. So, therefore, E2 is equal to, here n square is there, 4 into E1 we have to write it is. Now, you able to consider it is E3 is equal to, what we have to write it is E3 is equal to 9 into E1 and so on you have to take. So, therefore, these are the energy spectrum, energy is what it is this energy. So, n is equal to 4 you have to take. So, E4 is equal to 16 into E1 we have to get. This energy is energy spectrum in one dimensional box is the discrete spectrum. Which spectrum it is? Energy spectrum is discrete spectrum, correct? This energy spectrum is a discrete energy spectrum, but the ground state is equal to, we have to write it is, so we able to take that ground state is equal to n is equal to 1. So, therefore, the energy is quantized discrete spectrum, the energy is quantized in terms of what? So, in terms of phi square h cut square is divided by 2m L square. So, the energy is quantized by, so phi square h cut square is divided by 2m L square. How we have to write the conclusion once you have to see? The length of the one dimensional box is, same for symmetric box. Maybe evening I have to teach to you for anti-symmetric box how it will be variable, those things also I will discuss. The length of the one dimensional box is for symmetric is same. The energy does not does not depend on the position of that box. The energy does not depend on the position. Does not depend on the position means if you able to consider, so the particle where it is existing does not depend on position means the energy does not depend on length. So energy does not depend on length because the length of the dimensional box is same for the symmetrical box. That's why it is not depending on the energy, does not depend on the position. Energy is depending upon only the number of variables only. Suppose if you want to take a two-dimensional box, if you have to consider, so what is the two-dimensional box? Maybe able to consider this is the x-axis. Now you have to write it as a y-axis, you able to take. So at x is equal to 0, this is the two-dimensional box, you able to write. This is the diagram. Now you have to define the potential of the two-dimensional box. V of x comma y is equal to, how we have to define 0. So when it will be 0, so 0 it will come when 0 is less than x is less than a, and so we have to write it is 0 is less than y is less than a or is less than b, you have to consider. This is the less than b, you able to take. When it will be infinite, so it is infinite. So when it will be infinite, when x is less than or equal to 0 and x is greater than or equal to a, and y is less than or equal to 0 and y is greater than or equal to b, in such cases our potential function you have to define. So if you have to solve the similar fashion, you able to get the wave function psi of x comma y is equal to what we have to get. Your wave function is so square root of 2 by a, the square root of 2 by b into sine, we are going to write it is nx phi x is divided by a into sine, we have to write it is ny phi y is divided by b, we are going to get it. So nx phi x is divided by a, ny phi y is divided by b, this is the sin x, where n square is equal to nx square plus ny square, where n square is equal to nx square plus ny square. Your energy value E is equal to what we have to write it is, so it is phi square h cut square is divided by 2m into phi square h cut square is divided by 2m into nx square is divided by a square plus ny square is divided by b square, you are going to get. This is the energy value. So what we are taking, where nx is equal to ny is equal to, we are going to take it as a 1 comma 2 comma 3 comma 4, and you have to take where k square is equal to, how you have to write it is kx square plus ky square, you have to write. You able to get these values that directly I am giving. So because similar fashion you have to solve for 2D box also. So not only that, so if you able to take not only 2D box, if you have to consider as a 3-dimensional box, you able to take. So what is your 3-dimensional box? Exactly you are writing as a cubical box. Your cubical box is going to take it as a 3-dimensional box. Your cubical box is going to take it as a 3-dimensional box. Maybe you have to consider as x-axis and y-axis and z-axis you able to consider. Now you have to define the potential V of x comma y comma z is equal to, how we are going to define the potential 0. When it will become 0, your potential is 0. 0 is less than x, 0 is less than x is less than a. So 0 is less than y is less than b, 0 is less than z is less than c is there. So now you have to write it is those things. Now you have to get it is when it will become infinite. So when x is less than or equal to 0 and when x is so less than or equal to 0 and when x is greater than or equal to a. Similarly, n y is less than or equal to 0, and y is greater than or equal to b. Similarly, when z is less than or equal to 0, when z is greater than or equal to c. So, this is the definition of what it is corresponding to the potential. If you have to solve this potential, you are able to get it psi of x comma y comma z is equal to square root of we need to take 2 by a into square root of 2 by b into square root of, we have to write it is the square root of 2 by a, the square root of 2 by b. So, we have to take here what we have to write it is. So, we are going to write the square root of 2 by c. So, the square root of 2 by a into 2 by b into 2 by c is equal to into sine, we have to write it is nx 5x is divided by a into sine ny 5y, ny 5y is divided by c into sine, we are going to take nz 5z is divided by c, we have to write it is, this is the sin x, where you able to write it is n square is equal to nx square plus ny square plus nz square, where k square is equal to kx square plus ky square plus kz square. Now, you need to write the energy value. How you able to write your energy value? So, that energy value how to write it is the 3-dimensional box, you able to take E corresponding to nx comma ny comma nz is equal to phi square h cut square is divided by 2m into, we have to write it is nx square by a square plus ny square is divided by b square plus nz square is divided by c square is there. So, this is your expression where your nx is equal to ny is equal to nz is equal to what is your values 1 comma 2 comma 3 comma 4 comma and so on it will come, because here zeros you won't get it, clear. So, this is very important application. This is the energy expression for a 3-dimensional box. What is that? The energy expression for the 3-dimensional box, we are going to take E nx ny nz, so is equal to, you are going to get it. Now, we need to take the probability density, how we have to calculate. We have to calculate the probability density, how we have to calculate once you have to see. You know that the probability density curves I am going to give, how we have to going to give the probability density curves you able to see. The 1-dimensional box length is equal to 0 to L. So, the probability in y axis you have to consider as a modulus of psi square, you have to consider modulus of psi square x is equal to 0 to L. Now, you able to take here the first curve, you are going to get it. So, this is the first curve you are going to get, the peak value you are going to get it whenever, where you are going to get it exactly middle. Now, you have to take when n is equal to what, you have to consider as n is equal to 1. If n is equal to 1, you able to get it is exactly peak value you are going to get. If n is equal to 2, so what is going to happen once you have to see, you able to get that 2 peak values you are going to get it, this is the n is equal to 2. Now, you able to take n is equal to 3, you are going to take it as n is equal to 3. How many peak values you are going to get it? So, you are going to get, so your peak values are going to get it, how many peak values you are going to get? Your n is equal to 3, you have to see here. So, 3 peak values you are going to get. So, 3 peak values you are going to get it, your n is equal to 3, 3 peak values you are going to get it is n is equal to 3. How we are going to get once you have to see? The probability is equal to, what is the formula for the probability? The probability is equal to, we know that the probability So the probability is equal to, so the probability is equal to the P of x is equal to, what we have to write, it is modulus of psi square into dx. This is the probability. Now we know that the probability is equal to, what we have to write, it is the probability is equal to modulus of psi square is equal to, for a one dimensional, 2 by a, you have to take it as a x is equal to a, you have to consider here. So 2 by a into sine, which one we have to write, it is n phi x is divided by a, sine n phi x is divided by a whole square, that is sine square n phi x is divided by a into dx. Now you have to write it as a probability density. What is your probability density? The probability density is equal to, so the probability density is equal to, how much we have to write, it is 2 by a into sine square n phi x is divided by a. So the probability density is equal to 2 by a into, the probability density is equal to 2 by a into sine square n phi x a is divided by a. When it will be maximum, the probability density, when it will be maximum, you have to see. Suppose if you able to take, so the probability density is equal to, the probability density is equal to, what is your probability density? Your probability density is equal to, your probability density is equal to 2 by a into sine square n phi x is divided by a. So when it will be maximum, so this probability density is maximum, this probability density is maximum. When it will be maximum, it is maximum when this probability density is maximum, when, so when it will be maximum, n phi x is divided by a is equal to, if it is a maximum 90, sine 90 phi by a, comma, which one we have to write, it is so phi by a. So 3 phi by 2, phi by 2 you have to write, it is, this is maximum at phi by 2. Now 3 phi by 2 and comma 5 pi by 2 and so on you have to take. So this is the maximum condition. Now you have to write it is x is equal to, you are able to compare these two. First you have to compare, x is equal to, what we have to write, it is 5a is divided by 2n phi. So 2n phi, 5 get cancelled, we able to take it as x is equal to a by 2n, we are writing x is equal to a by 2n. Now you have to write here, you able to take here also, you have to compare these two. So what is going to happen when x is equal to 3 5a is divided by 2n 5 into, so 2n 5, this 5 get cancelled, therefore 3a is divided by 2n. Now the similarly you able to write it is 5a is divided by 2n 5. So therefore 5 get cancelled, we have to write it as 5a is divided by 2n when xn is equal to. When xn is equal to, this is the position, if you have to write it is, if n is equal to 1 you have to observe, if n is equal to 1, the first energy level, that is the ground state, you have to observe. So you, if n is equal to 1, your x is equal to a by 2, n is equal to 1, you have to write it is, your x is equal to a by 2, the particle found at the middle. So where it is, the particle is found, the particle is found, where it is found, the particle is found at middle. If n is equal to 1, the particle is found at middle. If n is equal to 2, if n is equal to 2, what is going to happen? Your xn is equal to, if n is equal to 2, your x2, 2 values you are going to get. So a by 4, comma, so 3a by is divided by 4. So 3a by 4, these two values. So the particle is found.
So, 2 values, the particle is found at a by 4 and 3a by 4. So, this is the exactly a by 2, this one is a by 4, and this one you have to take it as a 3a by 4. The particle is found at 2 places. Now, the similarly you have to write it is, if n is equal to 3, if n is equal to 3, the particle is found. So, where it is found? The particle is found a by 6, comma 3a by 6, so comma 3a by 6, and you have to take it as a 5a by 6. That particle is found in 3 places. So, what is this place? A by 6, so 3a by 6, and this place is 5a by 6. So, the particle is found in different places, the particle is going to take it as a granted, clear. So, like this you have to do. So, this is that. From this we have to conclude the probability of the particle being present, the probability of particle is being present, the probability of particle is being present. How we have to write the particle, the probability of particle being present, we need to take the probability of particle is being present is different for different quantum numbers. For n is equal to 1, the particle is existing a by 2. If n is equal to 2, the particle is existing in somewhere. So, therefore, the probability of the particle being present, so the probability of particle is being present means found is different for different quantum numbers. This is very important derivation we are going to write it is. So, today is enough. So, today evening I want to take that some more important addition of the one dimensional box. So, one dimensional box is not finished. So, please practice it. Once you have to practice, then only you able to get the perfection, clear. So, like this we have to apply the Schrodinger wave equation. This is the first application of eigenvalue problems particle in one dimensional box, correct. So, please practice and learn and study and meditate, and you have to teach to your students. Thank you.